Hello, good afternoon or good morning, depending of where in the world you're watching. Welcome to the A4Q World Congress on the first day. So today we're joined by one very amazing speaker. So we have here with us Adam Liam Smith. He is the Chief Technology Officer of Dragonfly, a European consultancy training and products firm that specializes in the intersection of AI and quality. So, Adam, I'm not gonna take too much of your time, so you can have a little discussion. I just would like to say to everyone watching that this is a live presentation. So, if you do have any questions, more than welcome to put your questions in the comment section down below, and then at the end we can do a very quick Q&A. And also, I'm going to be sharing in a couple of minutes the Gather Town link, which is the virtual Congress hall, where you can also go afterwards and watch or talk with some of the speakers that we have had today as well. So Adam, I will pass this on to you now. Thank you so much for joining us as well.
Thank you very much, Andrea. Okay, everybody. So I'm here today to talk about DevOps. Now, I'm going to talk about what DevOps is a little bit, but the main thing I want to talk about is the need for testing specialists to be trained and certified in DevOps and why that's important, and some ideas about what such a training course or a certification might look like. I'll take questions at the end, but I also really like to get feedback at the end. Do people think it's a good idea? Is the content the right sort of thing they'd expect to see? So I think this is probably going to be about 20-25 minutes discussion. So let's get started. So Andrea introduced me already. So just to put a bit of color on that. So I'm CTO of Dragonfly, which is both a consultancy specializing in technical quality matters and also a products firm. Now, on the consultancy side, all of the small businesses and startups that I work with these days are going straight to DevOps culture and DevOps tools and DevOps practices. And I'll talk a little bit about what I mean, but I'm seeing this at every small company I work with, and some of the large ones as well, even the really big multinationals that you wouldn't expect to be adopting things so quickly. Now, as well as on the consultancy side, having led a team on the product side, we've recently been on a journey of adopting DevOps cultures, tools, and practices in our own product development team, which has been a fascinating journey. And I've learned quite a lot along the way about how you actually need to test your DevOps implementations. I'm also chair of the British Computer Society's software testing group, and I do quite a lot of podcasting for Ministry of Testing and have a podcast called Fuzzy Quality. My Twitter ID and email is on the screen. I'll also post those on the comments section in a little while in case you want to contact me and haven't noted them down. So I did a Twitter poll last week. So it's not very statistically significant, but I found it really, really interesting how many people in my network thought that technical testing specialists do want to learn DevOps skills. And the reason I did that was because increasingly I'm having conversations with test automation specialists who are saying to me, how can I develop some understanding of DevOps? How can I increase my technical skills or understand how I can use my testing skills in a DevOps construct? But what is DevOps? You know, it's quite ephemeral. It's quite difficult to put your arms around it. I think it includes, from a tooling perspective, things like automation, things like CI/CD, containers, clusters, infrastructure as code, GitOps, and cloud. But there's lots and lots of different tools and there's lots of different approaches. It's a culture as well as a set of tools. It's a culture that integrates developers with IT operations. It aims to accelerate the delivery of high quality software through automation. With the advent of things like cloud, infrastructure as code, containers, microservices, we're starting to end up in a world where infrastructure is not something that someone builds and hands over. It's not part of your environment anymore that your test objects are deployed into. It is one of your test objects. Your servers can go through your CI/CD automated test system just like your software does. Now, the market, in terms of the numbers that various reports are showing, show that teams are increasingly describing themselves as DevOps. At the moment, it's around 25–30%. And the investment by venture capitalists, tool vendors, etc., into tools that fall under the banner of DevOps is also increasing rapidly. Some of you may be familiar with the Phoenix Project. So the Phoenix Project is the first novel I've ever read about releasing software. And it's all about a new head of IT who starts at a dysfunctional IT department. And he changes the way things work. He changes the way the developers work with operations, work with security, work with users. It's a really good book. If you haven't read it, I'd really recommend it. It is a really weird feeling reading about things like software releases in the context of a fictional novel. And it focuses much more on the culture side of things. It also focuses a lot on automation, but not on the specific tools and techniques that are in use. There's also a sequel to it called the Unicorn Project, which is on my to-do list to read. So in my effort to try and figure out what DevOps is, I looked at a Gartner report. Now, you can think what you like about Gartner reports, but I think this is kind of a good description of things that fall under DevOps. We have the collaborative nature of DevOps. We have the stakeholders being brought together across silos and structures being changed to ensure that communication works well. We have Agile. Agile's a core part of DevOps. The iterative nature of delivery of value. We have continuous. Continuous delivery is all about delivering change rapidly, and it's only possible if you have automation and you apply that automation systemically to everything. So all of these things are interesting, and they encompass almost everything. But what does this have to do with testers? What does it have to do, first of all, with testing processes? Well, testing teams and specialists often sit in between the developers and the operations and the users, both in terms of process, perhaps even in terms of physical location. Many teams I've worked with, the testing team is the one that's facing off directly to the operations team or to the users rather than the developers. So it's pretty difficult for testers to say, we're not going to change in a DevOps culture. There's also some interesting testing concepts in DevOps. There's shift left and shift right. So shifting left is all about shifting the testing processes upstream into the development processes. So one example of that is performance testing. Increasingly, we run performance testing in CI/CD. So we have batches in Jenkins that kick off JMeter jobs and things like that, rather than it being run once a release or once a year or whenever there's a problem. There's also increasing trends towards the use of static tools, things like code quality tools and things like that, being pushed into the build process and the build process being gated so that those tests have to pass before code comes out of a build. But it's not just about shifting left, it's also about shifting right. With some applications and some contexts, it can be very difficult to really prove that the users like and want what you're developing in a testing environment and a testing activity. So shifting right is about conducting structured testing in a production environment enabled by things like observability. So one example of that is the work done on contact tracing with teams all over the world, deploying apps to phones and then monitoring things like Splunk dashboards and things like that to see how effective things are being in the real world. When you have to deal with millions of people who have different habits, thousands of different device types, and things like Bluetooth proximity that's affected by things like bodies of water, walls, etc., that can all interfere with the process. So there's some testing concepts already, shifting left and shifting right. It's also about containerization and management of infrastructure as code. So it's a bit difficult to imagine sometimes what some of these things are. Containerization is essentially reducing a server to its smallest possible function and defining it in code rather than someone sitting and building, following a process to build. Let's take a really quick look at what that looks like. I'm not here to teach you right now, but just to give you an idea, this is what the definition of a container looks like. It's basically a script. there's a particular set of keywords and scripting language that allows me to define a server. This server in particular is a Selenium node. So I use the cloud to spin up Selenium Grid so that I can run testing against lots and lots of different apps and servers simultaneously. Now I can take this definition of a server and I can build it into a real thing. Now, it had already downloaded all the dependencies, so that was super fast, but that just created me this server. And then, apologize for the typing noise, I can literally run that server here. So now I'm running a server on my local machine that can accept Selenium tests if attached to a hub controller. So that's pretty cool. I can then take this and I can run this locally. I can run this in my CI server. Maybe I want to test this container. Maybe I build unit tests that test that the right ports are open and things like that when it starts on the CI server. So containerization is really important. Being able to download a container and test locally on your own, if you think about a microservice, that's a huge benefit. You don't have to wait for someone to deploy something. You don't have to wait for a developer to release something, an environments person to spin it up. You can just get started. But the other side of this is infrastructure as code and GitOps. So this is running your whole application's infrastructure within, again, code. Again, let's take a really quick look at what that looks like. So this is a grid of Selenium servers that I use. So this file, it starts by building a network, builds network subnets, IPs, firewalls, policies, builds everything for me. Now, why is this cool? Well, let's say I want to suddenly go from a grid of 3 Selenium servers to a grid of 1,000 servers. Can you imagine how long that would take if I wanted to do that manually? But what I can do, I can just take the container and I can create more of them. So I just made a change. I just added 997 servers to my grid. Now to build those servers, all I do is type this. And it's going to analyze my environment, my infrastructure. It's going to look at my local stored state. And it's going to build those servers. And that's going to take a matter of minutes. And then they will be attached to my grid. Now, I'm not going to actually do that because that'll use quite a lot of resources on my server farm. But hopefully that gives you a taster of how this sort of thing works. Another side of this is test automation. Without test automation, how can we have continuous high-quality software delivery? This is not just about creating and maintaining automated tests. It's about integrating them into CI and CD so that they're running as an intrinsic part of your delivery process. So what might people be able to do if they knew more about DevOps? Well, they might be able to configure and maintain CI themselves rather than relying on a DevOps or dev colleague. This is an interesting thing. I keep going to organizations that have DevOps teams. So a team has been created to sit in the middle of all of this, which kind of flies in the face of increased collaboration, really, if you create just another silo or just rename your infrastructure team. DevOps is really about both automation and collaboration. And being able to maintain automation in CI and CD is an important skill that testers need these days. That might require that they're able to integrate test automation with build automation tools. So an example of that would be Maven. If you're from a Java environment, you'll be familiar with how you can run things like Maven compile, Maven test, Maven integration test, and use that to link into your CI/CD. And of course, there's equivalent tools for all sorts of different languages that you might use. You might want to build and deploy your own test environment using infrastructure as code and cloud. That's suddenly a lot easier. All the time I've spent planning out who's using what environment as a test manager. Now I can just give the developer permission to start their own environment and do what they want in it and destroy it when they've finished. What about designing tests? When we work in this DevOps environment and we work with these clusters of microservices, there's actually some other things we need to think about that were less important before. So on performance testing, cost is now an output. Previously, you had a fixed environment and you determined, how fast things could run on that environment, how much resource utilization there was on that environment. Now my environments scale automatically. The more I performance test, the bigger they get. So the cost per transaction becomes something that you start to see in performance testing reports. Compatibility becomes increasingly important, where we have this loosely connected set of microservices and systems that are talking to each other in a cluster. Reliability becomes very important, and people design this in by default, but you've actually got to check things a bit differently, because the sort of modern systems will self-heal, because if something crashes, they'll spin up another one. You might not find problems just by testing the application. In the background, it might be churning away, spinning up new microservices while others are crashing. Maintainability. This is a key lesson learned for me in terms of implementing DevOps in my own team. The processes we had to introduce around things like using Terraform, as I just used there, to spin up servers, we just hadn't thought about. So if I run something on my machine, the state is stored on my local machine. And if some other developer runs something on the same environment, it doesn't know about that. So you've got to do a few things to make sure that the state can be shared and test that amongst the teams. You need your infrastructure to be able to move forwards and backwards easily in terms of releases and react to signals from monitoring tools and self-heal. Portability has a slightly new meaning. Increasingly, people care less about the operating system because it's all wrapped up inside that container, but they care more about being able to move their whole infrastructure between Azure, Google Cloud, and AWS very quickly. So these are some of the things that we need to think about. So what do I propose? I propose that there is a training and certification course that's designed for test automation specialists to be able to upskill in these areas and gain a foundational understanding of both the tooling and the automation required to support the sort of continuous delivery that's promoted under DevOps. This includes using source control, using continuous integration tools, using containers, using infrastructure as code, and an understanding of the key concepts of cloud computing, as well as covering how you might test differently in DevOps systems. I talked about shift left and shift right there. I think that any certification should enable students to explain the benefits of DevOps, to be able to do a gap analysis against their existing processes, perform basic tasks with the sorts of tools that I just showed there, and to be able to do enough with them that they understand the concepts, and to be able to test modern DevOps systems. I think the right people to go on this kind of training is people who are technical. They have test automation skills. They maybe have a bit of, they're used to using things like Git and some basic Java in order to wrap up their automation, or another programming language. I've got this idea for a course where we literally go through the process of taking an application, automating the build, automating the CI, automating some testing, and then spinning it up in a production environment, which I think would give learners a fantastic opportunity to really understand the end-to-end process. There's some challenges though. Some of the challenges are actually making sure that learners have the ability to run all the tools on their kit. I think some laptops don't support virtualization. Many people don't have the admin rights on their machine to be able to install the tools they need to do. So this course would need to run in the cloud as well. And I think the course should focus on a Java and open source stack, because that's the most common one I see. It's certainly not the only one, but it's the most common one I see out there in the market right now. So as I said, I see this being a really interactive, hands-on learning, where learners understand the concepts of DevOps. They learn how to compile an application from source and see how the build automation works, to set up test automation inside something like Jenkins, to be able to run applications using containers, and then to be able to create the infrastructure to support the application they just built using infrastructure as code, and then execute things like resilience testing and functional testing on the actual infrastructure as code. If I have in my container, I'm going to expose port 22, and that's important, I might want to add some unit tests. So my container in Jenkins is tested itself, not the code that's deployed on it, but the actual container is checked during that CI process on its way to production. So that's it. That's my idea. It went down well on Twitter with a small sample, and I thought I'd come here today and see what this audience thinks. I think I can take questions now, but I'm also super interested in feedback on what people think about whether this is necessary, what people think about the tools that would be required, and what people think about the proposed content.
Hi, Adam. Such an interesting presentation. Thank you so much for sharing that with us. We actually do have already some comments for you and some feedback and questions. Let me just put them in the screen now. So for everyone that is watching, more than welcome to ask your questions now. I also shared your Twitter handle on the comment section down below. So if you're interested in Adam's Twitter, I've already put it in the comment section. So we have over here Edgar Chalilov, I hope I'm pronouncing your name correctly. He says, when automation tests should be added into the pipeline, how much percentage should be done? Hi there from Lithuania.
Hey, Lithuania. You should add automation tests to your pipeline on day one, because you're building and testing your pipeline. How much percentage should be done is a question that can only be answered by you. It is context dependent. How high risk is your application? How mature is it? What bits of the application are actually changing? There's not much point wrapping lots of tests around components that aren't changing. What about exception flows? Code coverage percentages don't include, for example, exception code, because the things like JVMs lose control of the flow of the program, so they don't record it as code coverage. If you're measuring in terms of your business requirements and business context, that's different, and you should be going for the highest percentage you possibly can, because those are the requirements your business is interested in.
I hope that answers your question, Edgar. I can see he also already commented, where can I find this course?
That's good feedback. The course hasn't been developed yet. I'm here today to seek feedback and see if people want this course.
There you go. You have some feedback there. And also he replied later on, it's okay, and a very good smiley face as well.
Thanks, Edgar.
And yes, thank you, he says now. So I can see over here as well, a couple of people say, thank you. And also a few people in the groups I can see over here are saying, very interesting presentation. Thank you, Adam. Another person is saying, thank you. They are asking something about the presentation. I'm not sure if you're referring to watching the test that maybe Adam did earlier. This session is actually being recorded. So if you would like to rewatch that, this is going to be available also to watch later on. If you're referring to the presentation of Adam, Adam, can we share your presentation?
I'm happy to share it. Absolutely, yes.
Okay, lovely. So then maybe just send us an email to Congress. I'm going to put the email address in the comment section in a moment. And if you do have, would like to get Adam's presentation, just send us an email and then we'll get in contact with Adam. Or as I said, Adam's Twitter is already in the comment section, so you can contact him as well if you would prefer.
And you can put my email address on the comments as well if anyone doesn't like.
Oh, lovely, lovely. I will put his email address as well. I can see Anna Day says yes to the course. And I have someone here saying hello from Italy. Hello, all the way to Italy.
Hey, Italy, ciao.
True, very true. Okay, so I can see those are the questions at the time being. So you have gotten very good feedback. So it looks like people is definitely interested in the course. I'm gonna just very quickly put the presentation on screen so people can also see Adam's email address. I'm gonna put it in the comment section as well. So that will be Adam at wearedragonfly.co in the comment section. So in that way, you can also copy that from there.
Thank you. If anyone is interested in the product that we've been developing using these DevOps principles, take a look at myneuro.ai. It's an engineering and quality management tool that helps with managing both remote teams and on-site teams. And
we have Edith also saying yes, indeed, to the course. So people are already excited for this course, indeed. And here I will put also Adam's email address on screen. So it's quite big now, so you can see as well. And it's also in the comment section, so you can also copy that later on. And this is being recorded, so if you do have more people interested, you can share this later on with them. I think that is it for the time being. So thank you so much, Adam, for joining us. And if anyone have any questions, just let us know. I also shared in the comment section the link to GatherTown, where many people is going to be talking with different hosts as well from different days, and also other participants that are watching. So if you are interested in that, go to the link I put. Check out our Congress Hall area here. If you click there, you will be able to go there as well. I don't know, Adam, if you would like to also maybe join over there as well to get some extra feedback on the course. Possibly, it sounds like people is quite interested as well.
Cool. I'll try.
Lovely. So thank you so much, everyone, for watching. This is going to be all for today. And stay tuned for the next presentation, actually, that we have coming up. 2 other presentations at 1 o'clock, so in about 30 minutes. So don't go away. Just stay over here, and we're going to go live again. Thank you so much. Take care.
Thank you. Enjoy the rest of the conference.